Okay, so for this video, I'll be covering problem 4 on discussion work. Electrons and lone pair electrons are shown in the molecule below. Complete the structure and use it to answer the next questions. So first we have to complete the structure. There are multiple bonds and lone pairs missing from the structure. So make sure all atoms are satisfying the octet rule and that they are surrounded by 8 electrons. So first, let's look at carbon has 4 electrons. It forms 4 covalent bonds. So looking at this structure, there are many carbon atoms with only 3 bonds. So let's fill in let's first fill in the missing bonds. So okay. So now that we have taken care of the missing bonds, let's look at the missing lone pairs. So make sure that all atoms are satisfying the octet rule. So for this, you're going to have to chloride, you're going to have to add 3 lone pairs. Oxygen, you're going to have to add 2 lone pairs. And nitrogen, you're going to have to add 1 lone pair. So now that we have completed the structure, let's answer the following questions. So what is the hybridization of the starred atoms? So if you look at the starred atoms, carbon, nitrogen, and oxygen, they all have 3 electron pairs in a trigonal planar arrangement of atomic orbitals. So you have 3 sp2 hybrid orbitals with 120-degree angles between them. All of these starred atoms have double bonds, which always corresponds to 1 sigma bond. All of these starred atoms exhibit sp2 hybridization. They have 3 sp2 orbitals forming those sigma bonds, and the p orbitals are forming that pi bond. So carbon, nitrogen, and oxygen, all the starred atoms exhibit sp2 hybridization. So how many lone pairs of electrons are present in this compound? So we drew those out, so all we have to do is count them. So 1, 2, 3, 4, 5, and 6. So there are 6 lone pairs in this compound. Okay, so the last question, which of the starred atoms is represented by the energy diagram shown below? So the particular combinations of standard atomic orbitals added together determines the shape and energy of hybrid orbitals formed. So the energy of the hybrid orbitals is the average of the atomic orbital used to form them. So if we look at this energy diagram, all of these hybrid orbitals have the same energy. So you should know that 4 sp3 hybrid orbitals have the same energy. So that is what this energy diagram is telling us. It's telling us that this atom exhibits sp3 hybridization. So we already know that all of our starred atoms exhibit sp2 hybridization. So the answer would be that none of the starred atoms are represented by this diagram. Because if our energy diagram with sp2 hybrid orbitals would have to look more like this. We have 3 sp2 hybrid orbitals and 1 leftover unhybridized p orbital. That is higher in energy.